Hello, everyone. Thanks for having me. It's great to be part of ScalaCon. Well, I'm here today to tell you a bit of what I've learned since I joined as one of the maintainers of Quill, a library that I hope most of you already know. And I'd like to say, what was the motivation to talk about something so low level as ASTs? And actually, I learned that from a great engineer that nowadays is part of Netflix that said, to be a great developer, you should know 1 to 2 levels deep down of the platform where you are working with. And I decided to take it in the direction of the language and the frameworks that I'm using and learn a bit more of that tools and hopefully share a bit of that knowledge with you. Well, so first, who am I? I am Juliano. I'm a Brazilian living here in London. It's been some good 6 years or so. And as mentioned before, yes, I'm CTO at Broad. I have around 15 years of experience with building software with like some of the cool languages and a lot more time building software with the vintage ones, right? This is my Twitter and my website. And I tend to write some software open source on my free time when I can. It's been busy since I joined Broad. It's a very different challenge. Broad is a fintech that will help Brazilians to spend their monies overseas in a most affordable way. And have a look at the website. It's very cool. And as I said, I tend to spend a lot of my time, if not building, but at least studying open source. I took part in the Hackatoberfest and even in the Zio hackathon recently. It was pretty cool. And most of my time I spend working on Quill. Then again, if you are not familiar with Quill, Quill is a link for Scala that allow you to write regular Scala code that you generate your SQL in a very safe way. That is valid for a few other databases as well, but let's stick to SQL. It's easier to understand. So a simple example is this code right here. It's regular Scala code. And if you're using Quill, the only thing you have to do is to add this quote block around it. And after interpreting your code, you will have this safe SQL code here without having to touch nasty strings, just writing your plain, beautiful Scala code. Well, first, I think I should tell you, I've been thinking of how I can explain what's the idea behind what Quill does. And I thought about using an allegory to explain the idea. So I thought that maybe languages are a good allegory. So if you're not familiar with the next sentence, it seems a bit weird. No worries, I'll explain in a minute. But this is, as I mentioned, I'm a Brazilian, so I'm a Portuguese speaker. And this is a sentence in Portuguese, a very, very, very simple one, right? This sentence is made by a noun followed by an adjective, right? That's how it works in Portuguese. By the way, this sentence just means clean code, right? And why I'm saying that? Well, the concept of the way a Portuguese native speaker would think, in that case, when they are assembling a sentence, we have the context, we have a specific role in our mind that's intrinsic to that language, and then from that, we can translate a sentence, right? So, for instance, as a Brazilian, as a Portuguese speaker, if I think about that sentence in Spanish, what I would do is I would have to consider the same rule, that would be the noun and then the adjective, and then I would say código limpio. It's pretty easy for us in that sense because it's exactly the same. However, when you take this idea to an English speaker, what happens is that the rule changes. The rule will be the opposite in that case. You have the adjective first and then the noun. And from that point, we can generate the translation you need. In that case, clean code. For anyone that speaks more than one language, it's clear that the problem is in this set of rules. So if you're studying a language that has similar rules than all your language, In the case of Portuguese, let's say French and Italian and Spanish, they have very similar rules. A good part of the way that that language works is you already know how it works to some extent. So you have to learn about the translations. You have to learn new words and new conjugations. But most, or at least a good amount of those rules, they are already intrinsically part of the way you think. And then again, as an allegory, I think it works because that's exactly what the way that Quill does. That's the way that Quill works, because what we have is a specific context. The same way that we were parting from in the previous slide from the Portuguese language, if we start from Scala and we have this quote on the top, the quote where you're acquiring a fruit, giving a specific context that's Postgres or SQL Server, and applying the rules that Quill abstracts in its AST, we can translate that query for that specific translation generating a specific dialect, being for Postgres, MySQL, SQL Server, and whatnot. That's the main idea behind Quill, let's say, or at least that's the way I like to think about it. So, okay, let's start thinking a bit more about how we manipulate that code in order to generate the safe SQL for our application. Going back to that slide where we have a general idea of how Quill works, we have, again, that specific Scala regular code. We have a macro engine. We won't think of that much now. We have the Quill AST, and then we generate that SQL. And if this talk is mostly focused on how the AST of Quill works, and going back to the idea of how you can extract a concept, trying to apply it to somebody else, I'll try to do that at the end of this talk. So first of all, it's important to understand what's an abstract syntax tree. It's a topic that you see maybe you see that in uni, and probably won't make that much sense at uni. That's what happened to me. I remember well, or maybe not, but I remember the topic being there, and I didn't give it enough attention. But an AST is a data structure used by compilers, basically to make a representation of your program. The code we write will be extracted in an AST, that set of rules as a language does, and then later on translated to a language that your machine will understand, or the virtual machine will understand. This is just a generic example that what you can see in this slide, but even the Scala language has its all AST right here, right? This is a semi-complete Scala language AST, and you can see that actually yourself, if you want. You can open your console, and if you create this, for example, you have a case class here, and then you generate a list of person, and if you import this reflect runtime universe, you can use this method show reify people, and then when you show the tree, you have a representation of the AST of the Scala code itself. So let's have a look of how we make this representation in Quill, right? Because Quill has its all AST with all sorts of operations. Remember, we are mostly focusing on Quill was born initially to deal with SQL. We have Q Cassandra nowadays and Spark, and we can deal with other databases, but let's stick to SQL because it's the base of the tool. So looking at the Quill AST, the first one we have is the idea of a query, and a query represents database and collection actions, basically all the actions dealing directly with the database, being a sort by or a group by, for instance. The next one is an operation that's basically between operands and operators, right? So we have the idea of an unary operation or a binary operation, a comparison, this sort of thing. The concept of action is basically a statement when you're inserting, updating, deleting, and whatnot. We have the concept of ordering, what represents, order, obviously. We have as well the idea of a value that it's an indication of a value in a specific context for the tool in general. The next one is a lift. It represents lifted values and structures from outside the quotation scope, meaning that a value that's being provided via a method. For instance, in compile time, we still don't have a way to use that value, so we have to lift it. It's mostly used internally, but if you are receiving a method from the outside, a variable from outside your method, you have to lift that as well. The next one is an iterable operation that handles collections and collection operations, obviously. And another interesting one is the option operation, because it has everything related to options. It's probably the best representation of having a specific abstraction for Quill, in the sense of, for the Scala language, there's not a big difference. For the SQL database, there's no difference because there's no idea of option exactly. And this is one that will be used later on to make an example out of something that exists in a context but doesn't exist in another one. And at the very end, we have a few other elements that don't exactly fit in any of the major categories of Quill AST, the ones that I call the lone wolves. So in this slide right here, we have a general idea of how we can represent everything that happens in Quill, mostly focus on SQL. If you think of a few of the other modules, let's say Cassandra, for instance, you have some specific AST just in that module to represent that specific database. It's not the case for SQL, but this is the complete-ish AST that is used in almost everywhere in Quill. So let's show you lots and lots of drawing. Let's have a look at the code and how that works. So let's say we have this case class person it's a very simple case class with ID, name, and age. And just to represent a connection, who would be in the database, let's say we have an address that has foreign key, that's an option, and other fields. So from the moment when I create initial quote, that's a query of person, and if I try to print out that AST, I'll have this very simplified AST right here. That's an entity of person, right? If I make it slightly more complex and I just add a filter by age, let's say, and print out that AST, as you can see here, it adds many other elements to our AST, where you have now a way to identify that specific entity. We have already a binary operation, and you have representation of that, the operator and operands happening here. If besides filtering, we add, let's say, a map operation, you see that AST keeps growing. Now we have something that to indicate not just the filter, but which one is the specific attribute that we're looking for with that map. That's the property identity down there. And if we try to make it this a bit more complex, using a left join, for instance, you will see that our AST will become significantly more complicated. We have like a lot of information around here to make sure to represent what that code is doing behind the scenes. Okay, but if I extract the AST, I have my own representation, my own rules of that code that I built looking at that code and analyzing that code. What do I do with that? Well, we have the idea of tokens and tokenizers. And a token is basically a sequence of characters that can be treated as a unit in the grammar of the programming languages. That's a very complicated explanation. But basically, keywords, identifiers, operators, they are all tokens in its all context, right? Given that what we will do is translate our Scala code to that is SQL idiom, we need to define a few of these tokens and these tokenizers. So this is basically the definition of a token and a few of its implementation. So we can have what's a tag token, we have what's a string token, what's a quotation tag token. Those are mostly used by the macro engine in order to extract more information from the code that will be provided to a quote. Besides that, we have scalar tokens, statements, and sets. And as you can see, all of them here, they will become a representation. They'll have it's all representation in a string format that will be used later on. We are overriding to a string because when we look at the main trait AST, you see that it's already using a tokenizer here because every element of an AST, it will have this, oh, my bad. We'll have this token to a string here. And every single one of them will have a specific tokenizer that we'll know, that you find through implicits which one is the appropriate tokenizer for that specific piece of the AST, later on generating the string in the shape we were expecting for our specific dialect. So I think we can try to walk through a tokenization altogether. I think that's the easiest way to do it. And to do so, you have to look at a bit more of the behind the scenes in Quill. So we have the idea of, we have in the class SQL query, we have this case class called flattened SQL query. That's mainly the case class that will retain all the information of select statement, right? So as you can see, we have that in order, not in the natural order right here, but we have everything we need in a select, from, where, group by, order by, etc. So from the moment when we receive that and we start to normalize the content of that AST before generating the SQL, what we do is we execute that in order, right? So initially, we will try to flatten the idea of checking if there's a distinct. From the moment when I can find that distinct, if it's present over there, I'll generate this, through the partner matching here, I'll generate this statement distinct tokenizer with what will generate something more or less like that at this point, right? Distinct and whatever comes next. In the next moment, when you try to tokenize the next element of that statement, this distinct from, with from would be the next one. We will go through the AST again, and well, obviously we'll have a from, so we'll have this statement at this point, select T from T. When you try to analyze the next step with where, finding the where, let's assume we always have all the conditions in this statement. We will generate a distinct from where something. Going to the next one, we'll have with group by, that will be present as well. That will generate this SQL at this point. And then we will have order by as well. Order by will generate, according to that criteria, something like that. And then you have the limits that will be present as well. And then we generate this code here, distinct from where, group by, order by, limit. And then we add the select at the end because it's the easiest one, right? So this with limit offset is everything we had before. We just add that to this string, to this statement right here, generating this. This is a very simplified walkthrough, the way we flatten the SQL query, because the whole process of normalization involves like many other steps. I believe this is, yeah, most of them are here. And as you can see, you can have to flag the option operations, simplify checks. There are many things we have to do in order to have that safe query produced by the tool through the method normalize. So, okay, if we go back to the code we had before and think of executing, or better said, let's interpret the AST using a Quill context. And so let's bring this as SQL mirror context. That's just a way to generate the SQL without actually trying to execute that. Bringing this context tooling, we can call the method run. And then going back to the same ASTs we had before, the moment when I try to run that K1, that's this quote right here, a query person, a very simple quote, that will generate this SQL right here. When you go to the next one, that's the query that had a simple filter by age that will generate this other SQL right here. The next one, filter and map, that has this already much bigger AST that will be translated to this SQL right here. And that very complex AST we had for the left join right here, that generates that massive AST, will be translated to something much simpler. That's just this SQL right here. Interesting enough, sometimes a few of those ASTs, doesn't matter how big or small they are, they will have a much bigger or much smaller outcome than other ASTs. And how does it work? Well, that takes us to the next concept that's important to understand how Quill does that. That's the concept called beta reduction. And what's a beta reduction? Well, let's use as an example options, the way that options work inside of Quill. Because remember, we have the person with an ID, and the address has an FK that's an option of int or long, right? So they will generate those ASTs right here, and they are very similar, but they are slightly different, right? They have these slightly different ways to evaluate the operation that compares those IDs, because one has an option, the other one doesn't. As you can see here, the second one has the option exists action that's part of the option operation AST. And interesting enough, when we actually run those queries, we produce pretty much the same query. And how is that possible? How does it happen? Well, that's when we apply the concept of a beta reduction, what is basically the process of calculating a result from the application of a function to an expression. I really try to find a better explanation of what it does, but basically it's just substitution. At some point, when you realize that you have one element of that AST that has an equivalent value to another one, you just substitute them, right? Like, you don't have to interpret absolutely everything. Sometimes you just take a part of that. So going back to our options, for instance, we have this verification here in flatten option operation. And as you can see, there's a moment when you apply the beta reduction in the body of the option exists. And then we have other elements, reason why we pass the entries later as well. But giving a specific condition, we have to reduce what's in the AST. So I think it's fair to say we skip some of those elements, or we just replace them with their own content sometimes. At least that's the idea of using an option, right? You have that binary operation inside of an option. If you know that the option is there, there's a value in that option, I just ignore the option itself, and then I can just use the operation inside of it, right? The same is valid as well for these other operations, and they are even more clear in the case of like option map and option for all, because you always have this the replacement in that case, because there's no difference for as mentioned before, there's absolutely no difference for the database if you're using an option or not. It's just expecting to receive that binary operation that you tell it if it should or should not be part of the SQL query, should or should not be part of that specific outcome. And then this is a concept that brings like some interesting ideas, because if you think of it, at some point we are just dropping some code, right? Of course, it's a well-defined concept, but at some point we are just removing code that we don't use or that we don't need, giving some specific conditions. Those are still, to some extent, laws we are following when interpreting that code. But this concept, if you extract that a little bit, it can be useful somewhere else. And this somewhere else is related to optimizations, right? So what if we try to apply this concept of beta reduction when you switch to we are replacing part of the code with something else, or as I said before, we skip part of the code because we know that's not that useful in that very moment. So if you look at this code right here, we have a quote that's a function that, giving a string that's drinks or not, we will filter out people that have an age that's inferior to 21. Otherwise, we will bring all the people in our query. So if I take this quote right here and I print its AST, what I'll have is this AST right here, right? Where you can see you have the list, and then you have if is one of those, it's a part of Quill AST as well. And given a binary operation with a specific value, we have one piece of the AST, or otherwise we have another piece of the AST. So the moment when I print it out, passing the value, as you can see right here on the top, it still uses the whole AST, right? However, this comparison here seems very, very trivial. And knowing that this is always true, because this is still compile time, right? Knowing this is true, we could use just this part of the AST, right? I mean, we know by now that the other part is not that useful anymore. So there's this idea of what we call the trivially checkable, because I mean, even though I can do that, it's not that simple, right? I cannot take the risk of just start dropping people's code. But it's a concept that could be explored. So given that AST matches what we call something that's trivially checkable, what's a concept that it fits with that idea of comparing two very simple strings, right? I could say, okay, if I know that's this one, it's true, otherwise it's false. I can already evaluate that. This is similar to the concept of beta reduction, but outside of the context of beta reduction, where I look at the code and I'm replacing that with something that's equivalent. So what I do is, if I know that those two are, both of them are trivially checkable, I could generate this constant of true or false. And going back to the code that will actually evaluate that, I can say if it's if that AST fits with an if that's a trivial condition, true condition in the first case, I know that the then clause is the clause that I need here. If it's a trivially false condition, I know that the else clause is what I need. Else clause is the one I'm using, meaning that I can just drop the other one. I just need one of them, right? For the record, this is kind of experimental. As you can see here, messages dot reduce trivials means that you have to actively pass a flag to Quill in order to activate this functionality. Okay, if we go back to our code right here, we have that execution with the pretty print and the AST of drinks. But this time, when I have drinks as the string, that will generate just the filter AST. So we remove the possibility of being using the other one, and we removed actually the outside of it as well. So suddenly we have a little less that we need to evaluate in order to generate the proper SQL query that we are looking for. Otherwise, if we use, if the input of our function is whatever else, the same applies. So suddenly our AST is much, much, much simpler than it was initially, and we still generate exactly what we were expecting, the proper outcome expected. I find this very interesting optimization in this sense of, that's pretty trivially what the compiler does, isn't it? What the compiler does is try to execute your code in the most performatic way. And what we do here is, in a very rudimentary way, we are trying to apply that concept where we are trying to be smart, or making Quill smart enough that it can remove some of the unnecessary parts of the code on that specific moment for that specific execution. And I honestly find it fascinating, because it was a lot of, there's a lot there just to do the optimization of a simple if. So it shows how complex a compiler can be, and that we have a lot to learn from that we could apply building such a tool. But yeah, when I was preparing this presentation, I was talking to someone in my team, and he asked me, how can I use that on my everyday life? Does it have any practical way to use that in my everyday life when I'm coding? And I'm like, honestly, not exactly, not exactly all the time, unless you decide to write your own Quill. However, I think that the knowledge there can actually be useful, or at least a fraction of that knowledge can be very useful even in your everyday life. So one of these days, I was writing some code that would use a Java library. And because it's a Java library, I actually have to convert my Scala objects to Java objects, or to a Java util map. That's still a Java object, right? And it's very annoying to do it yourself. And at some point, I realized that I could use some of the knowledge I acquired working on Quill in order to generate that code to me. So I wouldn't have to do it myself. So I came up with the idea of building a very, very, very simplified AST. And basically what I had was that I just need one AST with a value that would be any ref or a Java object, right? And I had this idea where I could have just a leaf where I have the final object, and every node would have a map of a string and any ref, where string is the name of that field. The idea was simple, was to turn a case class into a Java map, right? And I decided to apply this concept to see if I could just do it myself, make the compiler do it for me, actually. So what I did was actually a very simple solution. I basically had to, I create this, I don't have the code here because it's not that finished and not very well polished yet. But the idea was that I could have this map to JMap from any of my case classes that would generate this result that you can see right here in the format of a Java map for me. That's a representation, only a representation. And even though I had to use other concepts, like I had to use derivation from Scala 3 as well to do that for me. That's another topic. Because because I'm familiar with Quill, with the idea of having my own AST to represent that specific problem I'm trying to solve, I came up with the idea of doing the same because it's a much simpler problem to deal with. So my AST has like two possible elements, and with that I could just create the representation of my code, and then I just had to translate it to a Java map. And interesting enough, remember what I said in the very beginning of how we can, the heavy lifting is mostly on the way we define the AST. Because from this point on, I could translate it to somebody else. And eventually, after finishing this code, I realized that I could very easily just translate it to something else. I could easily translate it to JSON if I wanted, because I applied the knowledge I acquired there, right? So back from that whole idea of working in a tool that involves concepts that the most likely you won't use in your everyday life, I would say that it's likely you would. It's very possible you. Another good example, by the way, is I was watching the YouTube video by the Zio channel, the Zio maintainers, where they are writing Zio from scratch. And there are moments, they don't talk about it in that sense, but there are moments where they have clearly an AST as well. Zio has its own AST that becomes clear when you are building your effects, because you have what I think they call effect and the flat map, and they have their own crazy classes that represent what's going on before execution. So if you have this knowledge about the ASTs, you look at that, they're like, I know what's going on here. It's just a representation for something else. So even though maybe you won't write it yourself, that knowledge is very, very useful when you are studying more tools or going deep, deep inside other tools as well. As I said, the idea of learning 1 or 2 levels deeper of the environment, of having a better knowledge of your environment, of the tooling, that will make you a better programmer. Whew, that was a long journey. Okay, I don't know you guys, but I'm tired now. Like, it's been a long journey. So what you learned today? Well, the compiler is your friend. That first and foremost, you have your AST that you define your domain. You can define your own AST that you define your domain. Through the AST, you can make it follow the rules. You can manipulate what happens from that point on, because you have your AST that's your bread and butter from that moment. You then can normalize that, and then you can transform it. You can build outputs. And from the moment when you know how to do it, when you know how to follow those rules, and you have the concept of reduction, you can start optimizing. That's when you try to improve how your code works. It's a massive challenge, and it's very deeply interesting. I strongly recommend. If you'd like to start contributing to a tool like that, why not start contributing to Quill, right? It's a very nice project. Alex has been working on Proto-Quill for Scala 3. It's a very interesting project where you actually deal with macros and derivation and whatnot. And Alex has been doing a great job. Kind of recently, Quill, it was being announced that Quill will be part of the Zio umbrella. What I think it's a great thing. It's good when you have even more maintainers and people that wrote Zio. They're great developers. I'm pretty sure that was a good decision to have more and more, a bigger community responsible for such a nice project that I really enjoy working with. I think we have questions during the quick Q&A. So yeah, that was I hope you guys enjoyed. Thank you very much. We are done. Thank you very much.